Let's be honest, have you ever looked at the field of machine learning and just felt overwhelmed? It's like staring at this huge, unmapped mountain range. It's vast, it's complex, and it is so easy to get lost. Well, today, we've got the map. We are going on a grand tour of the entire machine learning landscape, guided by this incredible end-to-end syllabus that promises to take us from base camp all the way to the highest peaks. So let's gear up and start the expedition.
And the guide we're drawing from today, it does not mess around. The goal here is to be the definitive guide, a single document to take you from the absolute basics all the way to the cutting edge. I mean, that's a huge claim, right? It totally sets the stage for what's going to be an incredible journey. And that really is the big question, isn't it? If you're going to conquer this field, what's the path? What are the waypoints? What's the gear you need in your backpack? And what are the major peaks you have to summit along the way? Well, this explainer is your answer. This is the map that lays it all out.
Okay, so before we start any journey, it's a pretty good idea to know where we're actually going. So, first up, what is our destination? What is machine learning at its absolute core?
So here's the most important part. Instead of writing a million lines of if-then rules, we just give the computer a ton of data and let it figure out the rules for itself. I love how the source calls it a powerful function approximator. Just think of it like this. You're not just programming a machine, you're teaching it. You show it thousands of pictures of cats, and eventually it learns what a cat looks like on its own. It approximates the function of catness. It's a fundamental shift in how we build things.
All right, destination defined. Now, you wouldn't try to climb a mountain in flip-flops, right? In machine learning, your climbing gear, that's mathematics. This is the foundational toolkit you absolutely have to have packed before you even think about starting the ascent.
And what I love about this framing is how it describes each field. Linear algebra isn't just a bunch of numbers, it's the actual language we use to talk about data. Calculus isn't just about finding slopes, it's the engine that lets our models get better and better. And probability and statistics, that's our framework for dealing with the messiness and uncertainty of the real world. See, these aren't just classes you have to pass, they're the active tools you'll be using every single day on the climb.
And this formula right here is a perfect example. Bayes' rule isn't some abstract equation you memorize for a test. It's the beating heart of a whole branch of machine learning. All it's really saying is, here's a mathematical way to update your beliefs about the world as you get new evidence. It's how our models learn and adapt in a principled way. It's foundational.
With our toolkit packed and ready, we can finally start the climb. This first major ascent is going to take us through the classic foundational models of machine learning. The real workhorses of the field. Let's see what's on the trail.
So, right out of the gate, you hit a fork in the road. On one path, you've got supervised learning. This is where we have the right answers. The data is labeled. We're teaching the model by example, like predicting a house's price based on thousands of other houses where we already know the price. The other path? Unsupervised learning. That's where things get mysterious. There are no labels. The goal is just to find hidden structures, like finding natural groupings of customers in your data without any hints.
And as we hike up this first part of the mountain, we pass all these classic landmarks. You'll start with something really intuitive, like linear regression. You're literally just drawing the best line through a bunch of dots. Then you get to more complex terrain, with things like decision trees, which make choices in a kind of flowchart. And eventually, you learn to combine lots of them together to make a super powerful model. Each one of these is a vital tool for the journey.
Okay, so after mastering the classics, the climb gets way steeper, but the views get absolutely spectacular. We are now entering the territory of deep learning, the revolution that has completely defined modern AI.
I mean, just look at this progression. It's incredible. It all starts with the basic idea of a neural network. But then, these specialized architectures pop up. CNNs came along and basically gave computers eyes, totally mastering image recognition. Then RNNs gave them a sense of memory, letting them understand sequences and language. And then, the transformer arrived. This is the architecture that is so powerful it is now the backbone of pretty much all the mind-blowing AI you see today.
And this whole revolution didn't just give us the power to understand data, but to create new data from scratch. As you can see from this chart, the power of these generative models has just exploded. We started with early ideas like VAEs and GANs, which were cool, but look at the jump in complexity and impact with diffusion models. That's the tech behind all those stunning AI images you see everywhere. This is the creative frontier, right here. So, we've climbed the mountain, we've reached the summit of modeling. The journey's over, right? Well, not if you want to do this for a living. For professionals, building a great model is just a beginning. A whole new, even harder journey starts when you try to make that model actually work in the real world.
This slide is so important for understanding the professional world. In academia, the goal is often about creating a new algorithm or getting a new high score on some data set, but in production, the entire game changes. Your focus shifts completely to things like system reliability, making it work for millions of users, and constantly monitoring it to make sure its performance doesn't degrade over time, what we call drift.
And this right here is the professional's checklist. It's not just about the model anymore. It's about ML ops, building automated, reliable systems. It's about being able to handle massive amounts of data. And it's about crucial ideas like explainability. You know, if your model denies someone a loan, you can't just throw up your hands and say the computer said no. You have to be able to explain why. This is where the real-world responsibility comes in.
So, seeing this whole map laid out, it might feel a little daunting. But here's the really cool part. The source suggests this isn't some decade-long quest. With 6 to 12 months of really focused work, it's actually realistic to go from the math foundations all the way to advanced topics like transformers and ML ops. This makes the whole journey feel structured, and more importantly, it makes it feel achievable. And the sheer breadth of this thing is just incredible. We're talking about 28 distinct major topic areas. It really covers everything from the math we started with, all the way to these super specialized fields at the absolute frontier, like causal inference, reinforcement learning, and federated learning. It truly is the complete A to Z guide.
So there it is. The map is in your hands. Every trail, every peak, every single base camp is laid out for you. It shows the complete path, from the foundational foothills all the way to the frontiers of research and production. The only question left is, where are you going to take your first step?